So we're going to do some basic areas, formulas for areas, starting with a circle. As I mentioned before, a circle, its area is given by the formula A equals pi r squared. R is the radius of the circle, right? And notice the r squared will give you feet squared, centimeters squared, inches squared, etc. for your unit, so it is an area. The pi doesn't have any units. So the units all come from the r squared. A parallelogram is a four-sided closed figure. Closed just means that the end of the fourth side is in the same place as the beginning of the first side. So parallelogram, and the opposite sides are parallel. So it's a four-sided closed figure, opposite sides are parallel. It's called a parallelogram. And its area is super simple. That's why I'm starting with this. Its area is base times height. Okay, and for this class, you would either be given the height or you'd be given the area and the base and you'd find the height. But so you don't have to use like an angle and trigonometry because we're not doing that. You would do that in pre-calc maybe. So it's just base times height, super simple. Area is base times height. And by that, of course, I mean the length of the base times the length of the height or whatever. Okay, so rectangles and squares are just parallelograms. The opposite sides are parallel. It's just that they've got the angle there is 90 degrees, and it turns out when you do that with a parallelogram, all four angles will be 90 degrees. And the height then just becomes the length of one of the sides, right? But it's still a parallelogram. Its area is still base times height. It's just more often we would use X and Y, or maybe L and W for length and width. L, probably use a cursive L so you can tell it's not a 1. Right, but length times width, X times Y, or B times H, doesn't matter what you call them. If you're doing a problem with rectangles, you usually draw the rectangle and you'll label it whatever you're going to call it. And so it's pretty straightforward from there, right? And then a square, the base and the height happen to be the same, so you use the same letter for them. You could use B and B or H and H, but most people use X and X. So you get base times height, which is X times X, which is X squared, okay? Which is where the word X squared comes from, because it's the area of a square. Pretty obvious, I suppose. A trapezoid is a four-sided closed figure where there's one pair, at least one pair of opposite sides are parallel. So a parallelogram is a special trapezoid. It's the two sides here would be parallel for a parallelogram, right? Most people think of a trapezoid when these sides aren't parallel, but it does include when they're parallel. It's just not very important to remember. So, but you need at least one pair of opposite sides to be parallel. And then those sides we'll call the bases. So there's two bases, this base and this base. And if these two aren't parallel, then these aren't the same length, right? Like here, this B is the same as this B, they're the same length. Here they're different lengths. And the problem here is, if you flip this thing upside down, you could think of this as the base, and if you leave it this way, it looks like this is the base. They have the same height, but it's the same area whether you flip it upside down or not. This trapezoid always has the same area, and so we can't just use B1 here, and we can't just use B2, so we have to use something that's a combination of the two, and what we do is we just average them. So the average of two numbers is just the number halfway between the two numbers, right? So you just average B1 and B2, and think of that, use that for the base instead of using B1 or B2. Okay, so it's just going to be the area is just going to be the average of B1 and B2 times the height. Okay, and so it looks like that. The average of B1 and B2 So to average two numbers, you add them and divide by 2, right? Average 3 numbers, you would add them and divide by 3, etc. So I'm averaging the two numbers and multiplying by the height. So you can still remember that as base times height. Okay. Finally, triangle. Triangle is also related to a parallelogram because a triangle is just half of a parallelogram. So since the area of a parallelogram is base times height, triangle is half of a parallelogram, so it'll be 1/2 base times height. A lot of people know this formula, but maybe they forgot why. Sometimes in grade school or high school, or middle school, they'll make you cut out triangles and fit them together so you can see it makes a parallelogram. You probably did that at some point, whether you remember it or not. Okay, so I'm just writing this out so you have it on your notes, because all these things are on PDFs as well. And the colors are mostly to help you follow things, especially when you're reading it later, right, on a PDF. So I took this first triangle, I made it a little bit smaller accidentally. Just took this, I copied and pasted it, but it's hard to paste it the same size because you have to drag it. And became kind of smaller. And then I had to flip it over and put it. So you turn it and flip it over and you get, so that's really, if you cut this out of cardboard, you could use, and made 2 copies of it, you could flip one over and put it next to it and you'd see you get this parallelogram. So notice the base and the height for the parallelogram is the same as the base and the height for the triangle, right? So the parallelogram, the area is base times height. The triangle, it's 1/2. And this is a obtuse angle, a triangle. It has an angle that's bigger than 90 degrees. And this is a acute triangle. All the angles are less than 90 degrees. And they just look different when you put them together. So I'm just showing you they both work. You can make a parallelogram out of two copies of the triangle. You can always do that. Another way to think of this, if you happen to not remember the area of a triangle formula, is that a triangle is like a trapezoid. It's like a trapezoid, except that the top base, B2, has been made length 0. See that? You just squeeze that down to like a single point, that line segment. And so the formula would be, you would average this one and 0. So you'd have B plus 0 over 2, which is B over 2 times H, which is 1/2 base times height. So that's just kind of a cool little way of relating the area of a triangle to a trapezoid. Most people find this a little easier, probably because they did this at some time in K through 12, at least once.